haw, hee hee haw. Oh, I mean e-learning. It's been 5 weeks since our quarantine started, and came the day we had to stay home. And your kind smile I've missed since we parted, but you miss my tie flips 1,000 times more. Where, oh where are you today? Why did you leave me here all alone? I searched the world over and thought I found students, but they closed the schools and we was home. Happy Friday, everybody. I got myself cleaned up. That was the first time I've ever had a pie in my face. And I tell you, you know what the worst thing about having a pie in your face is? It never ends. 3.141592653589793238462643382795028. And it goes on and on and on. In fact, on Monday, when I was driving into school, we can only go into school, the teachers, for a few hours on Monday. When I was driving into school, there wasn't hardly anybody on the road, but I noticed that the police officer pulled Mr. Pie over. And then I thought to myself, I guess Mr. Pie, he doesn't know when to stop. So, hopefully you enjoyed that. And so it is Friday. For those of you in math counts or want to do an online competition, we have one this morning at 11 a.m. It will take a half hour max out of your time. It starts immediately at 11. And so we are in the Elite 8 in the country. And last week was quite a barn burner. I was stressed out. I was turning my hair gray. But we need you and we need your score. And so here's the bracket. We're going against Indian Valley, I think, Eagles of Harleysville, Pennsylvania. The population, I have no idea. But it could be a tough one. And if we win, if you see the bracket, we're going to be in the Final Four. And that will be next week. And I don't know if my heart can take this much more. But you guys are doing a great job. And it makes a little fun and excitement to be in the big dance. And so make sure, if you want to be a part of that and you've never done it before, I will send you a username and password. And you just click on this on our school page. Just click on Online Math Counts Competition Day. You're all invited. Click on that, and we're glad to have you. So, the attendance form is right here. Make sure you are completing that. This week's attendance closes out on Sunday night. Monday morning, we will have next week's attendance. You need to finish the attendance for this week before Sunday night. Every once in a while, someone goes, I can't take attendance for last week. That was last week. This is this week, so make sure you get that done. So right now, pause the video, take this attendance before you forget, and then we'll get right back to you. So get the attendance taken. Pre-algebra today, it's going to be kind of strange because normally in school we've been talking about the Pythagorean theorem, we've been talking about simplifying square roots, and usually when we finish a chapter, which is what we did on Wednesday, we would have a review game, get into groups, see which group's going to win. Then the next day we'd take a test. And so, but there's no review games and there's no tests. So guess what? We are moving on. We're moving on up. Moving on up. And so we're switching gears, totally switching gears without any conclusion to the unit. And so get all that Pythagorean theorem stuff done and square root stuff and get all that done because we are now on to functions. And one of the greatest inventions of all time right here is the function machine. And so we got the one and the only function machine that is going to help us get an A+ on our homework tonight. And so we'll scroll down to pre-algebra and the notes and the assignment. Now, second page of the notes or the back of the notes, and those problems come out of a different pre-algebra book, and we're using those, but the problems are also on the worksheet itself. And so you might need to refer to that page, and I'll show you that. But everything here should be self-explanatory. We'll post the video here in a little bit. And don't forget to get your warm-ups done. Some of you are not doing that on Khan Academy. You get 3 a week. But if you forgot to do them last week, you might have 6. Or you forgot to do a couple last week and you did this week. Go under the previous tab. It might say it's late, but it probably won't be late. And so just get it done. And the logic problem's already done for this week. And so just the contest at 11 o'clock for today. And so get your warm-ups done. But we're going to talk and shift gears, and we're going to talk about functions. And so when we have a function, what in the world are those? These are things we talk about in algebra forever. You talk about them in Algebra 1, you talk about them in Algebra 2, you talk about them in pre-calculus, you talk about them in calculus, and you just keep talking about functions, and it all begins today. Dun, 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 dun. And so what is a function? Well, a function is you take numbers, and this is notes number 117. I forget to write that. It's notes number 117, so make sure you get that in the corner. And so what you have is a function. And there's things called function notation, and we're going to cover that in a few days, called f of x. But you don't have to worry about that today, because f of x is the same thing as y. But what we're going to do is we're going to take x values and we're going to plug them in, and out come y values. Pretty simple. And the function is going to do various things to these x values. The x values are called your input. If you want a fancy name for input, your x values are called the, can you read it? Whoops. The domain. And so your input values are also called your domain values. And then the function's going to do something to those x values. And then you're going to get y values, and those are going to be the output. Now there's a fancy name for the output. And the output value's fancy name, you see it right here? It's called the home on the range, where the deer and the antelope play, where solemn is heard a discouraging word, and the skies are not cloudy all day, except every other day. Here the skies are cloudy. So, here we go. We're going to show you what this function machine is all about. And so, you'll have a function, like y equals 1/2 x minus 3. And what you're going to do is, you have x values. Now, you can pick any old x values you want. You can have x be 10 billion if you want. You can x be, whatever you want. But I just got to turn it on my function machine and let it warm up a little bit. I think it's warming up. When it's ready, it says, plug it in, plug it in. And so I got to program it. And this is the function, 1/2 x minus 3. And what we're going to do is we're going to plug values into that. And so the values that I have are right here. We're going to plug in -4, -2, 0, 2, and 4. I could have picked anything I wanted, but I'm nice to you. And I picked even numbers because we're going to divide them by 2. So all we're going to do is take this -4 and we're going to plug it in, plug it in. So I got the function right here. And I got -4. And I'm going to plug it into my function machine right here. And then it's going to take, wherever this is, -4 times 1/2. What's half of -4? John? -2. Good job. And then Joseph, what's -2 minus 3? That'd be -5. Let's see. Where's my card? Whoa, I think it got stuck. Let's see. Whoa, let's see what we got. What came out? -5. Whoa. Got to hold it the right way. -4 went in, and -5 came out. That was amazing. We should try another one. Oh, we got the machine. Let's plug in -2. What do we think -2 is going to give us? Let's see here. I got to get this all program ready. We're going to plug -2 in. We plug it in. Plug it in, plug it in. What is half? What is half of -2 minus 3? Phoenix, what's half of -2? -1? And then what's -1 minus 3? And we get H minus. Oh no, we get -4. And so that's going to be a -4. Then guess what we're going to do? We're going to plug 0 in. This machine, it's not too tough for the machine. We take 0 and we plug it in. What is half of 0, Brody? -3. And Negative 3. Oh, E minus. No, that's, yeah, negative 3. Here we go, negative 3. And so math is full of patterns. And so we could keep doing this because, you know, this is kind of fun. That's negative 3. We could plug 2 into Neil. What is half of 2 minus 3? And you get negative 2. And you're like, I see a pattern. Because if the input numbers, the domain numbers were picked in a pattern, and this is a linear function, what does that mean? Well, we got lots to learn. And then you plug 4 in. Well, what would half of 4 be? Half of 4 is 2. We could plug that in. And we would get negative 1. There we go. Negative 1. Woo! And so these would be my functions. And that would be your table. Okay? And then we could reprogram. We could say, well, what's the next function? Oh, 2x minus 3. That was quick draw McGraw right there. And then notice this one doesn't have x values picked. Well, you can pick anything you want. Don't pick 9 billion. That's not going to be very good. Ethan, you know, not 7 square root 3 over 12. You know, Ethan, what would be the easiest number to pick? Yeah, 0. You'd always pick 0. And I just happen to have a 0 sitting here. And if you plug 0 in, you're going to take 0 times 2, which is not 20, and then you're going to subtract 3. Please excuse my dear Aunt Sally right there. And then we go, it's getting my hand. And you should get, oh, negative 3. 2 times 0 minus 3. So that'd give you negative 3. And you can pick whatever you wanted. You know, I just happen to have a 4 sitting around. If you got a 4 sitting around, you can plug in a 4. And if you plug the 4 in, you know, you'd get, oh, I think we have technical difficulties. And you would get 5. 5. And so, because 2 times 4 is 8, and 8 minus 3 is 5. And we're going to do something with these. And we could pick a negative 1. And we could plug it in. And since you don't have a function machine at home, you have to go, well, what's 2 times negative 1? That'd be negative 2. And then negative 2 minus 3 is negative 5. And notice on this problem, if I am not picking these numbers in a pattern, do not expect these numbers to be in a pattern. They won't be. Okay? And so we look at the next one. We have, remember what these bars mean? What do those bars mean, Owen? Make it positive? Well, yeah, but it's really never make it negative because that means absolute value. So the absolute value of a number is never negative. So if you plug 0 in, the absolute value of 0 is 0. And then 0 plus 4 is 4. If we plugged, what do you want to plug in? Ainsley? 3? Okay. What's the absolute value of 3? 3 plus 4, 7. What if you wanted to plug in, Xavier, what do you want to plug in? 8? Okay. What's the absolute value of 8? 8 plus 4, 12. What number you want to plug in? Peyton? Negative 5? Well, okay. What's the absolute value of a negative? Positive. 5 plus 4, 9. See, if we're just picking random numbers, we're just going to get these random answers, and you're not going to see anything like that. And then there's a function. We'll give you some toughies, even though we're not together. Where are we going to put me? I guess I'll put me down here. Bing, here's the function. Y equals negative 4. And so it doesn't matter what we're going to plug in. I got some numbers sitting here. I got 6. I got 0. I got negative 8. And so let's just write these down. 6, 0, negative 8. I only got 3 of them. I don't know where the other 2 went. And we plug this in. And we plug 6 in. Well, it's like, there's no x. Well, what is it subtracting 4? Is it multiplying by negative 4? Is it, what's it doing? And the thing is, I don't know. So I'm just going to, whoa. and you get negative 4. Wait. So what did it do to the 6 to get negative 4? It just said it was negative 4. So the answer is negative 4. It just said y is negative 4. Y is negative 4. You mean if I plug 0 in, it's like your parents said, we're going to get carry out at McDonald's tonight, and they didn't ask you. But I said I want. They didn't care. Mom and Dad already said where you're going. I plug 0 in for X, and what's it going to do to the X? Whoa, whoa, whoa. Negative 4. Y is negative 4. I told you Y is negative 4. We plug negative 8 in. What's it going to do to the negative 8? And it is Y is negative 4. And we'll have functions that just say Y equals, and we're going to figure out what those mean. And so we just want to introduce the concept of a function. You got that? Now we're going to do a couple examples of doing the problems backwards. If you can do it forwards and you can do it backwards, you're doing it pretty good. So let's do some that are backwards. 3 problems on the notes are going to be like the last couple on your homework. And it's going to be playing around of name that function. And you get all the answers and you have to say what it was doing to it. And so, for example, if 0 went in and 1 came out, I wonder what it did. 1 goes in, 2 came out, 2 goes in, 3. Well, I think they added 1. And so what did we do to X? We added 1. Well, let's look at this one. Negative 1 goes in, negative 3 came out. Well, I think we subtracted 2. Well, you did, but does it work on this line? It has to work on every single line. 0 goes in, 0 comes out. I didn't subtract 2. So just because it worked on one step doesn't mean it works on the next. Well, you didn't add nothing. Didn't add nothing. Does that mean you added something? 1 goes to 3. I added 2. 2 goes to 6. I added 4. No, see, it doesn't work that way. You got to do the same thing every time. So stop thinking adding. What should we be thinking? Max? Multiplying. And what are we multiplying by, Max? We're multiplying by 3. So the function would be 3 times x. 3 times negative 1 is negative 3. 3 times 0 is 0. 3 times 1 is 3. 2 times 3 is 6. 3 times 3 is 9. Nice job. Then you get the harder ones. Well, how do you go from 0 to a negative 2? Well, you know you're not multiplying by anything. Well, you could be. But you can't just be doing that. Because 0 times anything is 0. So to get to the minus 2, you'd have to have a minus 2 in your answer. And that is a huge, huge-o hinto right there. That if 0 goes to anything and there's a number, you're either adding that number or you're subtracting that number. Well, let's see if we're just subtracting 2. So let's see if it's x minus 2. Maybe that's my answer, x minus 2. Well, 1 goes to 1. I'm so confused. I thought 1 would go, 1 minus 2 would be negative 1. And then 2 minus 2 would be 0. And 3 minus 2 would be 1. But 4 minus 2 would be 2. Well, I just can't get this. Ian, what are we going to do? Wait. What could you multiply 1 by, Ian? And then when you subtract 2, you get 1. Well, if you add 2 more to 1, that'd be a 3. And if you add 2 more to 4, you get a 6. And then when you subtract 2, if you got a 7, that means I started with a 9. And if I subtracted 2 to get a 10, that means I started with a 12. So Ian, what do you multiply 1 by to get a 3? Or multiply 2 by to get a 6? Or 3 by to get a 9? Or 4 by, and that's a little squiggle, is a 12. Yeah, you'd multiply by 3. And so we could check this. If we took 4, plug it in. 3 times 4 is 12, and 12 minus 2 is 10. And so that is perfect. And so that's the hardest one. So that'd be the end of your homework. So your homework tonight actually is out of this other pre-algebra book, and it says copy and complete the values of tables, and do that. And then it has make these tables, and then it has these questions, then it has find the function for these. So how do you go from these to these? Multiply by 4. Did you hear me? Multiply by 4. And then how do you go from here to here? Well, maybe you don't want to go multiplying. Maybe you want to go adding, or maybe you want to go adding and multiplying, or multiplying then adding, which would be the way to go. And then how do you go from here? The two hardest ones are not 23 and 24, but actually 22 and 24 on that. And so those are your problems, but you don't really need that because we're going to skip. We got to combine some days because we're fitting to the end of the school year just on Monday, Wednesdays, and Fridays. We skip all the review games. We skip all the tests. So what I want you to do is you need to write down assignment number 117. And the front and these 2 pages on this are all you have to send me. Okay? So you get ready. If you need to sharpen your pencil, sharp mind. Dull pencil, not so sharp mind. And so we're going to get ready to get this homework started. What you do is the first problems on your homework, you got to scroll back to this page, and it actually tells you what numbers to fill into the charts. So for the first 4 problems, you're going to fill in these numbers and copy them down. And so the first one's -2, -1, 0, 1, and 2. And so we got to remember that, and here we go. -2, -1, 0, 1, and 2. -2, -1, 0, 1, and 2. And what we're going to do is we're going to multiply all those x values. We're going to plug it in, and we're going to get the y values. And so, Ryan, what's -2 times 2? -4. Great job. What's -1 times 2? -2. What's 0 times 2? 0. What's 1 times 2? 2. And what's 2 times 2, Ryan? 4. Great job. But now, since you are advanced and we got to cram all these days into a few days left of school when we're only going Monday, Wednesday, Fridays, we got to skip some stuff and combine some stuff. So we can't just plug it in and call it a day. We actually have to say that these are actually points. These are ordered pairs because the x-coordinate comes first and the y-coordinate comes second. And these are ordered pairs. And these 2 points of this function, we can study the graph of this function, which allows us to interpolate and extrapolate and do all kinds of things. When will the curve flatten or whatever? But all these are going to be straight lines. There's no curves on these. And so this is the x-axis and this is the y-axis. And so we're going to plot the point, and hopefully we all remember how to plot points, but just in case we don't, we're going to plot these points. These are all ordered pairs. We're going to plot them on the graph. And my oldest daughter, she goes, you know how the easiest way to explain this to people, how you plot the point -2, -4? She says you just swim over to the ladder and then you climb up and down the ladder. Well, of course, if it's negative, you're going down the ladder. So -2, -4, you swim over and you climb down. So that'd be right there. And then -1, -2, you swim over and you climb down. And then 0, 0 is right there. You don't swim over and you don't climb anywhere. 1, 2 means you swim over and climb up the ladder. Whoa, that was a big old point. And then 2, 4 would be swim over. And notice all these points make a straight line. And if one was way over here, that means you're wrong. Don't tell anybody, just erase it and get back in line. And so once you have those, you want to graph a straight line. Now, I got a cool thing here that will actually put arrows on the end of my line. And so when you make your line, you make the line this big, not short and little. You end it where the graph ends. And you don't go further. You don't just keep going down here while the line just keeps on going. Going. No. You just stop the line when the graph stops, okay? Now remember, for these next 4, for 8, 9, 10, they tell you what to plug in. -3, -2, -1, 0, 1. And so you're going to write in -3, -2, -1, 0. You know, you're just going to finish filling it in. Then multiply them all by -3, plot the points, see what happens. Okay? And that's the same for the first 4. So you can do that. But then we're going to get to problem number 11, okay? So problem number 11, everybody ready? Once we hit problem 11, if you come back up here, it doesn't tell you which numbers to pick. You can pick whichever numbers you want. Just pick them and plug them into the machine. But don't be picking 9 billion, because it's not going to fit on the graph. Just pick like 0 and 1, 2, or -1 and -2. Now, I noticed something on your worksheet, problem 14, 3x plus 7. For some reason, it didn't show up. And so we'll do that one with you. And so right down here, problem number 14. It's supposed to be y equals 3x plus 7. So how many points do you really need to make a line? Well, you really only need 2. But 2 could give you the wrong line, and then you wouldn't get the right answer. So like I can pick 0 and I can plug it in. Please excuse my dear Aunt Sally. We're going to multiply before we add. And you get 7. So swim over 0 and climb up 7, and you're right here at 0, 7. Then we're going to plug in a 1. 1 times 3 is 3, plus 7 is 10. And we go right 1 up 10, and that would end up being right here. Now you could pick 2. 2 times 3 is 6, plus 7 is 13. But notice, that's off my graph. I don't want to keep going off my graph. So guess what? You're going to have to pick negative numbers. Face your fears and plug it in. And so if we plug -1 in, -1 times 3 is -3 plus 7 is 4. And that means swim over 1 and up 4. Ooh, that's still lined up. Now, if they didn't line up, I could pick another one. The book, I think, says pick 4. You really only need 3, but don't just use 2. I am confident that I never make any mistakes. Well, I make lots of mistakes on these videos and everything else. And so you need to make sure you got this down. And so we're going to go here. We're going to graph our line. And voila. The graph ends, line ends, and you put arrows on your graph. Okay? Next thing we want is the hardest ones are 17 and 18. Well, let's do 18 together. You're going to pick values for x. You're going to multiply them by -3/4, which really means you're going to multiply by -3 and then divide by 4. Or you can divide by 4 and then multiply by -3. So, Tucker, what type of numbers would you want to pick if you're going to multiply by -3/4 so we get nice integer answers? What would we want to pick by? Well, yeah, we could pick 0. That's always nice. 0 times anything is 0, and 0 minus 1 would give me -1. Good job. But then what other number could we pick? Do we want to pick 1? You pick 1. 1 times -3/4 is -3/4 minus 1 is -1 3/4. This is not fun. Right 1, down 1 3/4. You like plot a partial square? Ugh. I want to avoid that like the coronavirus. I don't want any part of it. And so what type of numbers could we pick? Tucker, multiples of 4. That's very good. Did your mom tell you that? Oh, you got it on your own. Yes, I know. And so we plug in a 4. And see, when you plug in a 4, you can either multiply by -3 and get -12, and then divide by 4 and get -3, or the 4s would cancel. And -3 minus 1 is -4. And see, it's nice to keep things nice, and we have integer answers. And what would be another multiple of 4? Since Tucker said to pick multiples of 4, Lucas, what would be another one? 8, yes. And see, if you put an 8 here, then 8 divided by 4 would cancel and give you a 2, and 2 times -3 would be -6, minus 1 would give you -7. And so that would be 8, -7. Notice how that's a nice answer. You could pick -4. That's also a multiple of 4. And then that would just give you 3 minus 1 is 2. Let's see if that. Swim over 4 and up 2. And sure enough, that lines up. And we could be here all day picking points. We could pick points. We could pick points in between points. We could pick the ugly decimal ones. But guess what the answers would be? All these points would be plotted. And we'd plot points in between points and 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 points in between points. And then we plot points in between points and points in between points. And look what it'd be lining up. And so that's what we'd have. And so we would just line them up. And so you want to take your straight edge out. Look how nice that looks with straight edge. you know, you just take the edge of anything straight and you just draw right there, and then you turn it in. Okay? So we want to make sure you do that. Then for the last 4, you need the information from the top. And so you need to copy, for problem 21, you need to copy this chart on the worksheet. You need to copy problem 22. You need to copy problem 23. You need to copy problem 24. So problem 21, I'm going to try to remember it. 1, 2, 3, 4, 4, 8, 12, 16. So let's write this down. 1, 2, 3, 4, I declare a thumb war. 4, 8, 12 is you're really trying to figure out what the function is. But since we got the graphs and stuff, we're going to graph them, and I want to see your graphs. Right 1 up 4. So that's going to be right there. And then we're going to go right 2 up 8. And that's going to be right here. And then right 3 up 12. Well, that's not going to fit on the graph. That's okay. That's why when we graph it, we got arrows. Because the arrows are like graphing the points. And so we got the arrows and we got the graph. Now we got an extra line here because I just got happy cutting and pasting. But what we want to do is name the function. So this is y equals. But is that how you go from a 2 to an 8? No, and you got to do the same thing. So what is it? If we're not adding 3, Connor, what are we doing? Oh, we're multiplying by 4. Great job. So this answer is going to be y equals 4x. Ooh, that's a bad 4. And so y equals 4x. And 0 zeros on this graph, so I could fill that in. The hardest ones tonight are 22 and 24 because they're y equals blank x plus blank. It involves adding, multiplying, and then either adding or subtracting. So you could add a negative. And the problem 24 here, so I don't have to move my picture, is y equals blank x plus blank. These are the hardest ones, okay, because they're like double. So we'll see what you can do with those. And then we're going to notice patterns from the picture. So next week, we don't ever have to make a chart. We can just look at numbers and we can graph them. And that's called slope-intercept form. And that is next week. And so today, hopefully you're watching this before 11 a.m. And hopefully you'll compete with us at 11 a.m. against that school in Pennsylvania. Show those 7th and 8th graders that you're snipping at their heels. You're ready to run with the big dogs. And you can get them. And so we're looking forward to that. And so we miss all of you. We enjoy making these videos for you when the computer saves it, and then otherwise I got to reteach it 3 times. But you never know that, so that's okay. And so we miss all you guys, and so email me, let me know how it's going, and we look forward to seeing your work. And remember, do your warm-ups and participate at 11 today. We need you, okay? Look forward to it. Okay, bye-bye, guys.